All right, let's look at the first problem. It says, given the recursive definition, a sub k plus 1 equals negative 2 times a sub k, and your first term is 10, write the first 5 terms of the sequence. So the first term is 10. The second term would be negative 2 times 10. Third term, negative 2 times negative 20. And you just keep multiplying by negative 2. A comment on notation, it doesn't really send the right message to just close the brace out right here, because the sequence could go forever. It doesn't stop after the 5th term. So you list the first 5 terms, but then you say that you continue in that manner. So we'll come back for scoring in just a second. Writing the nth term of the sequence is a function of n. So hopefully you can see pretty clearly this is a geometric with a common ratio of negative 2. So the nth term would equal 10 multiplied by negative 2 n minus 1 times. So the exponent there of n minus 1. Okay, scoring. Each term in part A is worth half a point. So for a total of 2.5 points for that part. But then the notation where you have the open brace, you have the closed brace, and the comma dot dot dot. That's like a little finishing touch. We're going to give you half a point for notation for that. Okay. The rule over here, you need to have a sub n equals in order for your rule to make sense. And then negative 2 also needs to be in parentheses. So it's kind of an all or nothing for part B there. So 2 points for that, and that would add up to 5 points. Okay. Problem 2 here, given the recursive definition, a little more advanced. This one, it wouldn't hurt to slow down and just kind of say, like, what would this rule say if k was a 1? And so it would say a sub 3 is equal to 2 times a sub 2 minus 5 times a sub 1, which would be 2 times a sub 2 is 1 minus 5 times a sub 1, which is 1/5. And then just simplify it, so you'd have 2 minus 1, which is 1. A sub 4 then would be 2 times a sub 3 minus 5 times a sub 2. And you could get that just by going back up here and letting k equal 2. And so hopefully that makes sense that you would get this relationship. And so that would equal 2 times a sub 3 was 1, and then 5 times and a sub 2 was 1. And then simplifying this, you get negative 3. And then a sub 5 would simply be 2 times a sub 4 minus 5 times a sub 3. Same thing, just going up here and replacing all the k's with 3's. Like this. 3, 3, 3. Okay. And then you'd have 2 times a sub 4 is negative 3. And a sub 3 was negative, no, a sub 3 was 1. Simplify that, you get negative 11. So your final answer would be that the first term was 1/5, second term was 1, third term was 1, fourth term was negative 3, fifth term was negative 11. There we go, okay? And it's just 1 point for getting each term. All right, problem 3, I'm going to show a step that was not super necessary unless you weren't sure what to do with it. So you do want to be able to recognize this one as arithmetic. If you didn't notice it right away, expanding it a little bit would have helped. So like even without doing a lot of simplifying, you could just kind of say, well, the first term would have been 3 minus 2 times 26. And then the second term would have been 3 minus 2 times 27. And so hopefully you could see that, you know, this one, you know, has 26 negative 2's and this one has 27 negative 2's. So the only difference between these is you just keep adding another negative 2. And that would happen again if you just kind of think about what the next term would be. So that would be a good way to figure out that you are dealing with an arithmetic. The next thing you need to figure out is how many terms you have. If n started at 1, you would have had 125 terms. But since n started at 26, that means you missed out on the first 25 terms. So you'd have 100 terms here. So this would equal 100 terms divided by 2, multiplied by your first term, which would be 3. I'll figure this out in a second. For now, I'm just going to write 3 minus 2 times 26. There's your first term. And then added to your last term, which would be 3 minus 2 times 125. There you go. And then you could write 100 over 2, which would be 50, but I'm going to leave it as 100 over 2 simply because I'd rather multiply things by 100 than 50. So I'm going to leave it like that for a second, just as a strategy. And then let's simplify this. So you've got, let's see, what would be the easiest way to do this? All right, I'll just do it straightforwardly. So 2 times 26 is 52. 3 minus 52 is negative 49, I think so. And then 2 times 125, that's 250. And then you're doing 3 minus 250, which would be negative 247, I believe. And then adding these two together, you would end up with, I'll go this way, negative 296, like that. And then, so like I said, I saved the over 2 because I kind of want to cancel over here. So that way I just have to multiply 100 by negative, and I'm just going to divide the 2 in. So 148, there we go. Okay, so my final answer would be negative 148 with 2 zeros after it. There we go. Okay, so here's what we're going to do. We're going to give you 1 point for, well, you got to be able to use this formula in this one. So 1 point for figuring out that you had 100 terms being added together. 1 point for showing in your work that you knew to divide by 2. 1 point for, you could write 3 minus 2 times 26, or you could write negative 49. But 1 point for figuring out the first term there, and 1 point for figuring out the last term. So like this or like this. Oops. And that's 4 points, and so the 5th point is for getting the perfect answer when you're done. There we go. Okay, problem 4 here, just evaluating this. I do want to show 2 ways to do this. One method is to fall back on if in doubt, expand it out. So you could have just started expanding the terms, which would be 7 minus 0.7 plus, oops, this. Should have written smaller, huh? Story of my life. Okay, I'm gonna write smaller. 7 minus 0.7 plus 0.07 minus 1, 2, 3, 4, 5. Okay, and so from there, you could do kind of just like a little like subtotal type deal, and it's super cute. So if you were to add the first 2 terms together, what would you get? 6.3. And then if you add the third term in, then you get 6.37, right? And then if you add the fourth term in, you'd get 6.363. And if you add the next term in, you get another 7 there. And if you subtract that last term off, you'd get, there we go. And in your homework, they would oftentimes ask you to kind of add a sequence of partial sums, and this was kind of the type of problem where that could be pretty helpful. Well, that's just one method. So if you did something like that and you got this answer, then you got it. You got all the points. Another way to do this problem would be to use the sum formula for a finite geometric series where you're adding the first 6 terms. So another way to do the problem would be to say that you could have your first term, which would have been 7, times 1 minus your common ratio to the, in this case, 6th power, all over 1 minus your common ratio. And then just simplify this, which I don't know if I'm going to have room, but I'll try. So this would equal 7 times 1 minus 1 over a 1 with 1, 2, 3, 4, 5, 6 zeros after it. And then it's all over 1 plus 1/10 or 11/10, but I'm just going to save some space by multiplying by 10/11. Just flip and multiply early. And then 1 minus this number, so we'd have 7 over 1 for the 7, and then we'd end up with 1, 2, 3, 4, 5, 6 nines. When you subtract that over 1, 2, 3, 4, 5, yeah. And then we're going to multiply that by 10 over 11. There we go. And then you can cancel things down, for goodness sake. So like the 10s cancel, and then the 11 and this gigantic number with all the 9s could cancel as well. So you'd be left with 7 over 1 times, and then divide the 11 in, right? You could even go right to left or left to right. It won't say no. So you'd end up with, let's see, let's go this way. So 9, 0, 9, 0, 9. And then over 1 with 1, 2, 3, 4, 5. There we go. Now you just have to multiply the 7 in, which isn't that bad. It would be 6, 3, 6, 3, 6, 3. 1, 2, 3, 4, 5. Which, if you really think about it, is totally equal to that number right there. There we go. Either way. So if most people did it this way, so let's talk about some partial credit. I'll give you 3 points for having this in your work. Something equivalent to that. So, and then the last 2 points are for getting the answer perfect right there, okay? Similarly, if you did method 1, 3 points for expanding the terms, and then 2 points for getting the final answer right. There you go. There's your 5 points. For problem 6 and 7, evaluating the sum for part 6, you'd want to be able to recognize by expanding it out maybe that you're dealing with an infinite geometric. So it would equal with a common ratio of 1/2. So you could use the sum formula on it. So your first term in this case would be 3 times 1/2, which would be 3/4. I just got that by letting n equal 1. And then you'd have over 1 minus your common ratio. So that would equal 3/4 divided by 1/2. Flip and multiply and reduce your fraction, and you get 3/2. There we go. You do need to have work to qualify for any points. However, at the same time, multiple choice is brutal. It's all or nothing, whether you got it right or not. So either 5 or 0. You do need to have points in order to get you do need to show work in order to get any points over here. All right, problem 7 over here. This time your common ratio is -1/2, still geometric and infinite. Common ratios between -1 and 1, so you could totally use the sum formula on it. This time your first term would be 2, because if you plug 0 in, which is your lower bound here, then you'd end up with 2. And so over 1 minus your common ratio. And then you'd end up with 2 over 3/2. And then flip and multiply, and you get 4/3, which was A.